This is part 2 of an introductory series to the new microprocessor board, the SwiftIO. If you haven't checked out the first video, there'll be a link at the top of the screen right now. I suggest you go and view that first. On now then to the second example in the book. Very simple example, just flashing some coloured LEDs on and off. It describes the layout here with the individual pins needed to drive the LEDs, pictures of the LEDs with their positive indicated on them, and some resistors to limit the current. You should never connect LEDs directly to any circuit, they will just go pop. Looking at the resistor colour codes, I can see there red, brown, which is 220 ohms, a standard value for limiting current on LEDs. Let's now then take out the parts from our SwiftIO maker kit and put the thing together. In the kit then we have a little board to plug everything into, so that's fine. The supplied cables are all orange, which is a little disappointing. It's easy when you're starting out to make mistakes and connect things to the wrong pins. It would be nice if they were individually coloured. We have our LEDs and in the kit a bunch of resistors. Now these resistors have the 5-band colour code, unlike the 4-band code that was shown in the brochure, and that's sometimes difficult to read, not only because it's so small. Therefore I always like to check the values using my handy multimeter. Let's see what they are. There's no marking on, sometimes it's written or stamped on the bandolier there, but not in this case. And we're seeing 990 ohms. They're all the same colour code, so let's just check another one. 991 ohms. But these are nominally 1 kilo ohm resistors and not the 220 ohm ones that we need. No matter, I have a bunch of other cables and I have a bunch of resistors. Bring those into play, and these, just for the avoidance of doubt, 219 ohms, so 220 ohms. We are good to go. As it shows, the individual resistors just connect across above and below. Each row is joined together, but they're separated horizontally, and there's a break in the middle of the board, so you put the component across there like that. Now, again, although the positive side is indicated in the booklet, it doesn't actually tell you how to identify that. It's actually quite simple. If you look at any of the LEDs, providing you haven't chopped the legs off, there is always one that is longer than the other, and that is the positive leg. We know that the resistor is going to go to ground, so we put our LED across there with the longest pin to the right, and that's going to be connected with a blue cable. And as I mentioned, the resistor is going to go to ground. With all the components in place then, I'm a kind of belt and braces guy. I like to test things out, make sure that they're working at each step. Before we go and download the code to the board, we can just check that each of the LEDs is actually going to light. The end pin here is ground and the next pin in is 3.3 volts. So if we take the red connection now and connect that, then we can see the red LED lighting. Similarly, the green LED, and lastly the blue LED. Now that we have confidence that the LEDs are actually going to work, we can move on and look at the IDE and download the appropriate sketch. In the MadMachine IDE then we have loaded up the Rgb LED Sketch. As always, a little brief description, nothing too onerous, blinking each LED in turn with a delay of 1 second. Here we can see the definition of the pins they're attached to, and then the red, green and blue each being turned on for 1 second. We can see here, and from the green LED on the board, when I press the button it's now in the download mode. This will verify and download the sketch. The message compiling, and then the details of the sketch and the download. The board has rebooted and we can now see the LEDs cycling through the pattern. In the little booklet it suggests a coding challenge, which is to try simulating a traffic light. So I guess they mean going red, blue and then green, and then in the reverse direction. I wonder if we can do that. Here then is the sequence I've come up with. Red, red and amber and green to go. Goes back to amber and then to red. At least that's how it works in the UK. Here in Spain it just goes red, amber, green, but I thought that wasn't particularly exciting. Looking then in the modified sketch, you notice I changed one of the LEDs for a yellow one, so I've just renamed it yellow. The delay is still 2 seconds, so we put the red on, and then the red and yellow, and finally the green. Then it goes back to yellow, and finally back to red, and cycles around. You can see then that the syntax of the code here is very readable, and if you have any experience of Arduino, you'll have no problems at all playing with this. Until next time.